Okay, this is a continuation of 1.2. Previously, we were taking absolute value functions and translating them, moving them left or right or up and down. Now we're going to move into stretches and compressions. This is one of the more difficult topics in the entire book, and it's going to follow us throughout the rest of the book. So there's often a lot of confusion around this topic, so I really suggest, if you're not quite getting it, to keep working on it and not just kind of move on and hope that it's going to go away, because it's going to be really important, and it's going to help you be successful in the whole course if you can really understand this. Okay, so first, what a vertical stretch or just a stretch or compression is. Okay, so if we've got an absolute value function, kind of looks like a V. Okay, and if we change the width of that V, that can either be a stretch or a compression. Okay, now a vertical stretch means the points are going to be moving up or down. So if you have, say, the point 1, 1 and the point negative 1, 1 here and here, if you move those straight up, then that's going to make your V narrower. Okay, so that'd be a vertical stretch because those points are moving away vertically from the vertex. Okay, now if I took the point 1, 1 and moved it straight down, and also its reflection point over there, move those straight down, that would give me a wider V. So that would be a vertical compression. Those are moving closer down towards the vertex. Okay. Now here's the confusing part. So it's just, a wider or a narrower V. And the same thing is going to happen with a horizontal stretch or compression, because if I take this same point and I move it horizontally this way, and then its sister point over there, move those two out, then that's also going to widen it's going to give me a wider V. So I could get a wider V but with a horizontal stretch, so the points could be stretching out this way, or the roof could be coming down and squashing. That would be a vertical compression. Okay, and a horizontal compression would be the points moving in. Okay. Now, if you get just a wider or narrower V, why does it matter? Well, it's going to matter when I've got more complicated functions. Like a sine wave is not going to look the same as if you squish it as if you stretch it like that. It's not going to be the same thing. Okay. All right. So, anyways, this is going to happen when the A is just a number. So when I'm multiplying the whole function by a number, or when I'm multiplying the input. Okay, so when I'm multiplying the whole function by something, that's going to give me a vertical change, and when I multiply the inside of the function, the input, that's going to give me a horizontal change. The way I remember this, well, x is my horizontal axis, right? If I'm looking at an x-y axis, it's the horizontal axis. So if I'm multiplying the x directly, that's going to give me a horizontal change. Okay, here I'm not multiplying the x directly, I'm multiplying the whole function, and that's going to be a vertical change. Okay, all right, so let's look at this. So there's two different things that can happen when I'm multiplying on the outside like this. I can get a vertical stretch or a vertical compression. Okay. Now the way you can tell by looking at an equation if you got a vertical stretch or a vertical compression, just by looking at the value of the A. If the A is more than 1, then you're going to get a vertical stretch. Okay, and that means if the A is less than 1, you'll get a compression. Okay. Now remember, if you have negatives, that's just going to give you a reflection. So then, when I'm saying, I'm not meaning that A could be -3, because the negative would just do a reflection. Okay. So technically, I'm really talking about the absolute value of A is less than 1, and the absolute value of A is more than 1. Okay. So A here might be something like A could be 2 or 3 or 4 or 5, anything, right? Here I'm looking for something between 0 and 1, actually. So A might be 1/2 or 1/3 or 1/4 or 0.7 or something like that, okay? All right, so let's look at this example over here. So this says write g of x for a vertical stretch. I've got a vertical stretch. So I'm thinking vertical stretch. Okay, so my a is going to be more than 1. And it says the factor is 5. Okay, so I'm just going to take, that means I'm going to take 5 times f of x. Okay, so I've got this. And this is what g of x is going to equal, right? I'm writing an equation for g of x. I should have put that in. I'm going to take 5 times f of x, okay? What I'm going to do then is substitute in f of x, the whole thing. F of x equals all of this, right? So g of x then is going to equal 5 times, and I'm going to use parentheses to show 5 times all of that. Absolute value of x minus 2. Plus 3, okay? It's easy to make mistakes with simplifying this here. You can't distribute into absolute value, but I can distribute right there, okay? And then you do want to do that, and then also back there. I see a lot of times people will distribute to the x and the negative 2, but you can't do that. It is just illegal. You can't, okay? All right, so this is going to look like that for my final answer, okay? Also, very common, people give me a plus 3 at the end instead of a plus 15. They forgot to distribute the 5 to the end, okay? So there is my, this would be a vertical stretch by a factor of 5. So that means it's going to get narrower, right? It would be my v, all the points would be moving up away from the vertex. So it's going to be 5 times as narrow as the original function, okay? All right, so when we're over here, we've got 2 different brands. We've got a horizontal stretch and a horizontal compression. I'm just abbreviating there in the interest of space. Okay, so a horizontal stretch, that's going to give me a wider, those points are moving out, okay? And this is when you're going to get a horizontal stretch when your a value is actually less than 1. And you're going to get a horizontal compression when your a value is more than 1, okay? Because if you think about it, you got a vertical stretch that gave you a narrower v, okay? But you could get that same thing with a horizontal compression by squishing those points in towards the center, as you could from stretching them up, okay? And again, technically this is really the absolute value. Not worrying about reflections right now. We can do stretches and compressions with reflections, but we'll get to that a little later, okay? All right, so let's look at this. I'm going to write a function for g of x, a rule for g of x, all right? I've got a horizontal stretch, so looking here, now I know that my a value has to be less than 1, but wait a second, it says the factor is 3. Well, if my factor is 3 and it's supposed to be less than 1, instead of my factor being 3, if I need a to be less than 1, I'm going to use 1/3. Okay, so if it said the factor was 17, I do 1/17. So you're just going to take the reciprocal, so that can be confusing, okay? So then I'm thinking, okay, well, what do I want to do? Well, I'm taking f of, I need to put, this is going to be really my where I put the factor, okay? So g of x is going to equal f of 1/3 times x. Okay? All right, so just write that like so, and that means my input is 1/3, okay? So I'm inputting into this function where the x is, I'm going to replace that with 1/3 x, okay? So, so I'm thinking of writing f of 1/3 x, just replacing that with 1/3 x. Okay, now there's not really anything else I can do to simplify this because I don't have like terms in there. I can't simplify these two because one's inside absolute value and one isn't. So that is my solution. Okay. All right. So let's try it out again. So this says vertical stretch. So that's the first thing I'm going to have to do is figure out, well, what does that mean? Vertical stretch. Vertical stretch. That means I'm multiplying the outside of the function by something, the whole function by something, and I've got to have a value that's more than 1. Okay, since my factor is 4, that means a is going to be 4, right, in this problem. So I'm going to have 4 times, this is for g of x, so I always forget to write that. G of x is going to equal 4 times f of x. Okay, and that means I'm going to substitute now. F of x equals all of that, right? So g of x is going to equal 4 times the quantity x plus 2 minus 5. Okay, and then to simplify this, distribute, but you can't distribute inside the absolute value. So this is the best I can do. Don't forget 4 times negative 5, okay? So final answer, I just want to get the g of x in there. It's going to look like so. Okay? All right. Now let's, we've got a horizontal compression. So looking at a horizontal compression, my a value should be more than 1. Oh, look at this, but 3/5 is less than 1, okay? So if I want that to be a number more than 1, I'm just going to, I could do 1 over 3/5, but when you simplify that, it's just going to flip that around, okay? So my a value is going to be 5/3. It's the reciprocal of this because I need it to be more than 1, okay? So then I'm looking over here, okay, so g of x is going to be, I need to take my a value times the input. My a value here is 5/3. Okay, and then I just need to input that into function f. So my input here is that, so that means I'm just going to replace the x with 5/3 x. And there's not going to be much to simplify once you do that. In fact, that's it. Okay, and we can also combine these here. We've got 2 different transformations. I've got a horizontal stretch by a factor of 8, and then I've got a translation 10 units down. Okay, so I'm going to do these one by one. I'm just going to do them in the order that it's written in the problem. So first I'm going to do my horizontal stretch. Okay, so horizontal stretch, if I go back up to the top of the page, that's when I'm multiplying the inside for my horizontal change, and I've got a number that's less than 1. Okay, so a then is going to have to be the reciprocal of 8, which is 1/8. Okay, so I'm going to input 1/8 in inside the function. Okay, so I'll call this h of x. It doesn't have to be f of x and g of x. It can be any numbers, but I'm just doing this because there's going to be 2 different transformations, and I'm going to end with g. But you can call that one whatever you want, okay? But I'm going to input 1/8. That's going to be f of 1/8 x. Okay, so let's see. I'm inputting then 1/8 x into this. Okay, so now I've got, that's just after the horizontal stretch. And if that's all it asked me to do, I'd be done. But I still need to do the translation, so I'm going to do the 10 units down. So now I've got this, I'm going to take this and put this 10 units down. Okay, so g of x is going to be h of x minus 10. Right? When you add and subtract on the outside of the function, that's when you're going to move things up and down. So I'm going to input what I already had here. I'm using parentheses here to plug in all of that. That's what h of x is, right? Oh, and I forgot the absolute value symbol there. And I get the minus 10. Okay, now the parentheses actually don't do much here. I'm just going to combine the 1 and the negative 10. Okay, so really I'm just taking this and subtracting 10 from the outside, right? I was just kind of trying to show all of my work and my thought process. But if you're just looking at this and saying, oh, move down 10, so I'll subtract 10 from the 1, that's fine. That'll get you to the same place. Okay. All right, let's try the next page. Okay, next page we're going to look at graphing these stretches and compressions. Okay, so here first off I've got just some lines drawn. This is the line y equals x, and this is the line y equals 2x. And y equals x has a slope of 1, right? That means you'd go up 1 to the right 1 to get from point to point. Okay, and this one is going to have a slope of 2, and you could write that as 2 over 1. So I'm going to go up 2 to the right 1 to get to my next point there. Okay, so yeah, actually let's continue this. Up 1 to the right 1, up 1 to the right 1. I go up 2 to the right 1, up 2 to the right 1. Okay, now let's graph y equals 1/2 x. Okay, so let's think about y equals 1/2 x. Actually, I think I had it graphed here really lightly and it didn't print out, but that's okay. So this is going to have a slope of 1/2. So it still has a y-intercept of 0. I'm going to go up 1 to the right 2, up 1 to the right 2, and now I can actually see really lightly that it didn't show up very well. There's the line y equals 1/2 x. Okay. So the same kind of thing is actually going to happen with my absolute value functions. Okay, if you think about, here's y equals x. If you had y equals absolute value of x, the right side would look like that. The left side would just be a reflection of that. Okay, and if I had y equals 2x, there's the other side, or y equals the absolute value of 2x. Then I'm going to have that other piece. Okay, so the same kind of thing is going to happen. If you're thinking about the parent graph, which is graphed on down below here, when you've got an a value that's more than 1, your v is going to be narrower. Okay? And then when you've got an a value that's less than 1, like 1/2, your v is going to become wider, whether it's a stretch or compression, either way. Okay? So that's going to be useful when we're graphing these. Okay? So yes, the parts that are graphed on all these, I'm not going to write that on all of these, but for all of these, I've got my parent graph there. So you can call it f of x, but I put it in y equals form. Okay, so that's on all 4 of these. Okay, so let's look at a horizontal stretch. So if I take these points and stretch them horizontally, and this is a component that confuses a lot of people, but stretching horizontally means you're going to pull them out away from the center. Okay, so b, instead of being there, I'm going to pull it out. I'm going to do this by a factor of 2. So those are 1 to the right, 1 up. I'm going to make them 2 to the right, 1 up. Okay, and then my vertex is going to stay right there. So I'm going to call this b prime. That's my new point b, and this is going to be my new point c. Okay. Now, what a lot of people do, they say, oh, I moved C 1 unit to the right, so I'll move D 1 to the unit to the right. Well, that's not what you want to do. What you want to do is double the distance from the center. Okay, so here's the center of my V. That was 1 unit away, and I doubled it so that now it's 2 units away, right? So since this is already 2 units away, I want to double that. So I went 2 units. I want to go another 2 units then. Okay, so D prime, my new point D, is going to be out there, not right there. Okay, because if I put it here, then I'll have a kink in my V, and I won't have a straight line that I can draw through those 3 points. That's another way you can check it. Okay, so this 2 units away from the center. I want it to be 4 units away from the center. So A prime is going to be there. Okay, and my new, and you can use a ruler if you want to be neater. I'm just trying to do this quickly. I guess I should use a ruler. There's my new my new v, my new absolute value function that's been horizontally stretched, okay? So this one that I just drew, this one is wider, right? So then that means I know I need the a to be a number less than 1. So this doubled in width, but I actually want this to be wider, and it's a horizontal stretch. So horizontal change, I want it to be inside, right? Multiplying the x directly. So the thing that I just drew should look like this, okay? And then the factor there, if you're asked for the factor is actually 2 because it's doubled, but the a value is 1/2. So my a is 1/2. The factor is actually 2, okay? So that can be a little confusing, but the important thing is that you know how to graph these and know what equation relates to it, okay? All right, so let's look at a vertical stretch then, okay? Actually, let's stick with the horizontals. So let's do a horizontal compression. That was a horizontal stretch. We're moving those points out. Horizontal compression, we're going to move them in towards the center. So horizontally, my points are moving left and right. Okay, these are going to move in for it to be a compression. Everything is getting squished towards the center. Okay, and I'm just going to go half the distance again. So, you know, I'm putting those both 1/2 to the right and 1/2 to the left. This is 2 units to the right, so I'll put that 1 unit to the right. Okay, so then I'll draw my little v. And you can freehand that, no problem. Okay, so this would be A prime, and this is B prime in there. Don't have much space for this. But I think you get the idea. Those points are getting squished in towards the center, okay? Now, it's a horizontal change, so again, I want my A value inside, but this time it's going to be a horizontal compression. Okay, so this is going to give me a narrower parabola, right? So I'm looking at, oh, narrower, then I'm going to need an a value that's more than 1, okay? So this is going to be, I'm going on the inside, a value is more than 1. So that's going to look like so, okay? Okay, and the a value, yeah, here was 2, but the factor is actually the reciprocal of that. Okay, because I'm multiplying those distances by 1/2. Yeah, you're dividing them by 2, but that's the same as multiplying them by 1/2. The factor refers to what you're multiplying either the horizontal or the vertical distances by. Okay. All right, let's move on to the vertical side of things. So on this one, I'm going to have a vertical stretch. So these points are going to get stretched vertically. So that means they're going to travel away from the vertex in a vertical manner. So they're going to, in this case, they're going to go up. So that's 1 unit above the vertex. So I'm going to double that. This is 2 units above the vertex. I want to double that. That puts me there and there. And I do the same thing on the other side. Okay. And then I can draw in my V. Okay, so this was B prime, A prime, here's C prime, and D prime. So I'm trying to show, hey, those ones are moving up, okay? So my V got narrower, right? So that means, hey, I know it's going to have to be a number more than 1. And so these are doubled in distance. Okay, but hang on, it's a, so I know my A value is going to be 2. But I have to figure out, am I going to put the 2 inside or outside? Well, it's a vertical change. When I do horizontal, then I'm going inside the absolute value. But when I'm doing vertical, I'm going outside. So it's actually going to look like this, okay? And let's say I had y equals 3 times the absolute value of x. Well, that would just be, those points would be 3 times as high. So instead of being 1 unit above, that'd be 3 above. I'm just doing factors of 2 here, just to 2 or 1/2, just to make it easy to graph. Okay. All right, and then a vertical compression. So that means these points are going to move down towards the vertex. So I put that 1/2 because it's half of 1, a height of 1. Half of a height of 2 is 1, right? So the same thing happens over here. So those points are all moving straight down. Okay, and when those move down, I'm going to wind up with a absolute value function that looks wider than the parent function. Okay. B prime. Okay. All right. So I know when I've got a vertical change, my A value should be on the outside. This time, since it's getting wider, my A value is going to be 1/2. So it's going to look like that. And then the factor here is going to be 1/2 as well, because they're half the height that they used to be. Okay. All right. All right. So let's get to graphing our own functions on the next page. Okay. So some guidelines for graphing absolute value functions now that we've covered all of the translations, the reflections, and the stretches and compressions. Thing you want to do first is to find and plot the vertex. Once you got that in place, it's going to stay regardless of reflections, stretches, and compressions. Okay. Then you're going to lightly graph what I call the ghost function. I'll just call it the ghost here. Okay. That's without stretches or compressions. But do include any reflections. Okay. Now it's not absolutely necessary that you graph the ghost, but I think it's really helpful to see what's going on. Okay. And then this says graph the 5 critical points is what I'm looking for. The 5 critical points, really, if you just do 3 points for these, it's fine, but it's always good to do 5 just to make sure. Okay, so if you just do 3, I'm not even sure if I left enough room for 5 on these. I would be happy with 3, but I put 5 to make it official up there. Okay, and then you're going to do those by stretching or compressing what we have with the ghost. Okay, so let's run through this. So I'm going to start by finding my vertex. Okay, so my vertex, let's work on that. Okay, so to find my x coordinate, I'm just going to set the contents of the absolute value function equal to 0. And I'm going to solve that for x. Okay, so I'll start by subtracting 3 from both sides. Subtracted 3 from both sides. And now I want to get rid of the 1/2. So I'm going to multiply both sides by 2. I'm going to multiply the whole equation by 2. So that means x is going to equal -6. Okay, so there's the x coordinate of my vertex. The y coordinate is just this, right? So let's plot that, get that on the graph. -6, -2 goes right there. There's my vertex, and that's going to stay anchored, okay? Now I'm going to plot my ghost. So I'm thinking, is there any reflections? Do I have a negative in either of those slots? I don't. So this is going to open upwards. Okay, there is no reflection here. So that means I can get straight to drawing my ghost. So I'm just going to pretend there's no stretch or compression, even though I know there is because the 1/2. But my ghost, I'm just going to go up 1 to the right one, up 1 to the right one, up 1 to the left one, up 1 to the left one. Okay, and I'm going to lightly draw this because this is not going to be my, you could make it a dashed line or something like that, or just do it lightly in pencil. Okay, if I didn't have a stretch or compression, that's what we'd be looking at. Okay, but I do have a stretch or compression, and now here's where the thinking comes in. Okay, So this is how I think through these problems. I think first of all, is this going to be wider or narrower? Since I've got 1/2, a number less than 1, this is going to make this wider. Okay, and some people will just take that and go straight to graphing this, and it actually works okay for these. But you do want to know what kind of wider are you dealing with, because there's two ways that I can get a wider V, right? I could stretch the points out, that would be a horizontal stretch, or I could cave the roof in and move all those points down, that would be a vertical compression, and it's important you know the difference. Okay, so let's figure this out. So I'm looking at the position then of the 1/2, and I can see, oh, that's got to be a horizontal change because it's multiplying the x directly. It's inside the absolute value, so I've got a horizontal change. Okay, and then I'm thinking, okay, if I want horizontal movement, so if I can only move these points left or right, and I want a wider V, I'd have to move them out, right? So that's going to be a horizontal stretch. So then I'm putting these two things together, horizontal, wider. That means I've got to have horizontal stretch. Okay, so now I'm looking, well, what's my factor? Since that's 1/2, my factor is going to be 2. So I'm going to double the distance of these points from the center. Right, here's the center of the V. I'm going to double those distances. So this point is going to end up twice as far from the center. That's 2 units away. I want to double that. Okay. I want to double that as well. And now I've got my 5 critical points. Minimum of 3. 5's even better. And then I can graph this. And so I did this all with transformations. Yeah, you could have actually done an XY table. But the thing is, sometimes it can take you a long time to find the vertex. There's no guaranteeing you're going to find the vertex quickly with those, and it takes a lot longer. Okay, and then we can also apply this method to all sorts of other functions, and we're going to be doing that in the future. So it's important that you understand these and aren't just relying on XY tables. Okay? All right, let's try another. Last one. So my vertex, well, I'm going to take this for my x value. X plus 2 equals 0. So my x value is -2, and then this is my y value. So -2, -1. Okay, now I'm thinking, all I really need to worry about for the reflections, is there a negative on the outside? If there is, then it'll open down, but there isn't here. So this one's going to be opening upwards. Okay, that means I'm ready to graph the ghost. Up one to the right one, up one to the right one, up one to the left one, up one to the left one. Here is my ghost. Okay, and now I need to perform stretch or compression. Okay, so here's the hardest part, right? So I'm looking at this first, thinking, well, is that going to be wider or narrower? When I've got a number more than 1, it's going to be narrower. Okay, so my V is going to end up squished, right? Now, actually, I need to figure out, though, is that from moving these points in towards the middle, or is it from moving all of those points up? Because if those points all moved up, that would also make my V narrower. Okay? All right, so, hey, this is on the outside. Remember when I was on the inside, I had a horizontal change, but this is going to be a vertical change. Okay? Every time your A value's on the outside, you've got a vertical change. So vertical, I can only move these up or down. If I move them down, then my V will get wider. I want to move them up. Okay? So they're going to be moving vertically up away from the vertex. That's going to be a vertical stretch. Okay, now so far we've been doing 1/2 or 2. This time the A value is 3, so instead of just doubling that vertical distance, I'm going to triple it instead. Okay, so I'm thinking, oh, this is 1 unit above the vertex. I want to triple that, so I want this to be 3 units above the vertex. So like if this is the floor right here, I want to go 3 units above that. So 1, 2, 3. Okay, same thing over here. That's 1 unit above, so 1, 2, 3. Not 3 units above this, 3 units above the floor, right? And then, hey, this is 2 units right here. above the floor. I want to triple that, so I want that point to end up 6 units above the floor. So 1, 2, 3, 4, 5, 6. Okay, and the same thing's going to happen over there. It'll be a mirror reflection. Okay, and then, okay, so it just fit on the graph I gave you. I must have planned that out or something. And there is absolute value function with a vertical stretch of 3, and I've also got those translations there. Okay, and that is it for today.